Hi guys, in this video I'm going to do an example of a long-winded, or some would call it a complex expansion problem, which involves the expansion of this fifth power polynomial here. What we're going to do is we're going to show how we can use Pascal's triangle to help us expand this, but I'm not going to go into too much detail about the actual process of expanding this particular polynomial, just because I even have a video on a simpler version which will hopefully explain the mechanism by which we expand this in a lot more detail. So let's get down to business. First of all, what we need to do to expand this is we need to draw Pascal's, or write down Pascal's triangle up to the fifth row. Now, hopefully all of you guys are familiar with Pascal's triangle, and each term is derived from the two terms above it added together. So this is the fourth line of Pascal's triangle, and this is the fifth line. Cool. So this is the fifth line here. So what Pascal's triangle tells us is it tells us the values of each of the coefficients in our expansion, and it also tells us what the number of values that we're going to have. So in this row, we can see that the value is going to be 1, 5, 10, 10, 5, 1, but we also have 6 different values in the expansion. So that's what we're aiming for. The way that these expansions work is we're going to start with the first coefficient, which is 1. And what we then do is we're going to be timesing this by 3x squared all to the power of 5 times negative 2y cubed all to the power of 0. Cool. Then what we do is we're going to add the next one, which is going to be, we put a 5 out the front, 5, 3x squared inside the bracket, that will not change. But what we do is we drop the power from a 5 to a 4. And then we're going to multiply that by negative 2y cubed to the power of 1. Cool. So then we just move on to the next one. So the next one is 10. Again, 3x squared all to the power of, we drop the power again, 3 times negative 2y cubed to the power of 2. Add 10 again, 3x squared all to the power of, drop the power again, 2 times negative 2y cubed to the power of 3. So I'm going to move down to the next line. So we're going to add. So we're up to this term here now, 5. Now we have 3x squared. Now we drop the power again, so it goes to 1. Negative 2y cubed to the power of 4 plus 1 3x squared to the power of, drop the power again, 0 times negative 2y cubed all to the power of 5. Great. So what we've done here is we've literally done all of the terms as they're expressed in our Pascal's triangle. So what we can do to start with, before we move on to the next step, is we know that negative 2y cubed to the power of 0 is 1, so we can just disregard that term. And the same with 3x squared to the power of 0. That's just 1 as well. So we can disregard those terms now. So I'll change colour and I'll move on to the next step. So basically what we're going to do here is we're going to keep the 1 times, the reason I'm keeping the ones is just so you can see where Pascal's triangle influence quite easily. So this is going to be 1 times 3 to the power of 5, x to the power of 2 times 5, which is 10. Great. Then we're going to add 5. Then we have 3 to the power of 4. X to the power of 8. And then we have negative 2 to the power of 1. Y to the power of 3. Great. Plus, then we have 10 times 3 to the power of 3, x to the power of 6. Then we're going to go, this is negative 2 squared, y to the power of 6. And then we're going to go plus 10 again, times 3 squared, x to the 4, times negative 2 to the power of 3, y to the power of 9. So basically what we're doing here is we're just expanding all of the brackets and collecting, so we can collect all the indices. So this is going to be plus again, 5 times 3 to the power of 1, x to the power of 2, times negative 2 to the power of 4, y to the power of 12, times, then we just add 1 times negative 2 to the power of 5, y to the power of 15. And I'm happy that we can fit it all on the one line. That's great. Cool. So from here we can move on to basically our final step. And this is the step that you need to almost, if you're going to take time in any part of an expansion like this is the time to take your time. This is the time to take your time. So let's have a look. Our first term is we've got 3 to the 5. So we've got 3, 9, 27, 81, 243. X to the 10 plus, we've got 3 to the power of 4, which is, with 3 to the power of 4 is 81, times 5 is 405, times 2 is 810, but that's going to be a negative 810 because negative 2 to the power of 1 is still negative 2. So we're going to write negative 810, x to the power of 8, y to the power of 3. Then in the next step we have 3 cubed, which is 27, times 10, 270, times positive 4, 270 times 4 is 1080. So that's going to be positive 1080. X to the power of 6, y to the power of 6. Cool. So we're up to here now. So we have 3 squared is 9 times negative 8, because negative 2 to the power of 3 is negative 8. It's negative 72 times 10 is negative 720. And that's going to be x to the power of 4, y to the power of 9. Almost finished. So then we have 3 to the power of 1, which is 3, times 2 to the power of 4, which is 16, so times 5. So we have 15 times 16, which is 240. So that's going to be plus 240. and we've got x squared y to the 12. Cool. And finally, we've got, this is going to be plus 1 to 2 to the power of, negative 2 to the power of 5 is negative 32. And we have y to the power of 15. So, a question like this in a test, what I would do is unless you know that you're going to have a lot of time at the end of a test, I would try and get this one out of the way to start with, because this isn't the kind of question, because they're not usually worth too many marks, because the actual complexity of the question is not hard. It's the ability to get through the entire question without making a silly mistake, which, you know, is quite common when you have to do this much multiplication and addition and subtraction. So what I would recommend is you do this one first while you're fresh in a test, and you know, if you go through it, you know, nice and steady, you'll find that the marks that are available for a question like this will be basically yours guaranteed. So I hope that helped with your expansions of these type of polynomials. I'll do a couple more videos on these in the future, but if you have any specific problems, just let me know. Thanks.